In this lecture, we'll start with the introduction to the wireless networks hacking. Here, wireless networks hacking is nothing but we are supposed to choose a wireless device or a connected device via wirelessly, and we are trying to explore the connection strategy followed by the device with the communicating device, and we are trying to exploit that particular communication, or we can also say that the handshake that will happen between the devices, and we are supposed to try to exploit that communication so that we may gain the sensitive information such as passwords related to that particular device, or we may try to inject some fabricated packets into the device so that already communicating parties with the device may get confused that someone might have joined into the system. So these are the various activities that will be carried out in the wireless hacking or wireless networks hacking. Before moving on, first of all, we should have a thorough understanding of how protected you are from the open Wi-Fi connections. Nowadays, many places like the public places, especially like bus stops and bus stands, railway stations, airports, where you will find open Wi-Fi. That means you will be given a small password, and if you have a valid ticket, you can make use of the particular Wi-Fi connectivity. So, how protected you are from that particular open Wi-Fi connections? So, for what purpose? See, this will be decided based upon for what purpose you are using Wi-Fi. So, are you using this Wi-Fi for browsing the mails, or are you using this Wi-Fi for bank transactions, or are you using for electronic commerce transactions, or are you using for bill payments? So this matters. So whenever you connect to the open Wi-Fi, so it is always recommended that not to use any financial transactions. So for what purpose you are using Wi-Fi, based on that this query can be answered, and how much time you have spent on the open Wi-Fi. Okay, have you used the open Wi-Fi for around 2 seconds or 3 seconds, or maybe 2 minutes, or maybe 15 minutes, or 20 minutes, or continuously you are using? So as long you use the open Wi-Fi, so you will be having more, your system or device may be more vulnerable to that for attack. That I will explain afterwards why it is. Next is potential issues using the public Wi-Fi. So whatever the thing were identified with the questions like this, for what purpose you are doing, what is the time spent on the open Wi-Fi, based on that statistics says that research statistics says that the potential issues of making use of this uh, time spending of more time on the open Wi-Fi is leading into the identity theft, compromised accounts, fraudulent form filling, etc. So these are the most commonly performed attacks on the wireless devices that was connected to the open wireless connections and have performed the internet transactions. Identity theft is nothing but duplicating your identity or stealing your identity. It is mostly happen in the case of this Bollywood stars and all. Okay, they will tweet something and finally they'll say that, oh no, my Twitter handle was hacked or maybe tampered or something, some nonsense they will tell afterwards. So, but actually, God knows whether really they have made the comment, and after the troll what they have identified, then they reverted or returned back. Okay, I have taken the U-turn. Only God knows. But they keep on telling this kind of things that my Twitter handle was hacked, or Facebook handle was hacked, or Instagram handle was hacked. This kind of things used to say. But it may be possible. But it may be possible when it is possible actually. It is possible when they might have used this open Wi-Fi for a long time in the public places like airports, etc. So because to the same Wi-Fi, many may be connected. Anybody may connect to the Wi-Fi, and they may perform the transaction. So during the connectivity, they may also observe they may observe the routing table, which is available with the Wi-Fi router, and they may trace the IP addresses nearby. The attackers may do some work there to hack this particular thing and to get the identity theft, compromising of the accounts, fraudulent of form filling, etc. So genuinely, we can accept somewhat that okay, their Twitter handles were hacked or something. This may be due to the reason that they might have used the public Wi-Fi especially in the airports and some other places. But it is always advised for that not to use open Wi-Fi because I will tell you why it is when we go into technical details. Next is the same statistics also showing that greater than 60% of enterprises are using wireless devices and networking. That means almost all companies, including the educational institutions, the general from small scale to the large scale companies are making use of 60% of their enterprise was connected via wireless devices. Nowadays, 100% of smartphones are equipped with the wireless network. So you cannot find any device nowadays, smartphone especially, without wireless networking. Either it may be having a Wi-Fi connectivity or a Bluetooth connectivity, or any one of the form of connectivity will be available. Next is greater than 90% of the data flows through the wireless devices. So nowadays, because 60% of the enterprises are using wireless devices means only 40% are using the wired devices. So whatever the system hacking, application hacking, or web application hacking, SQL injection, that what we have seen so far are related to the wired networks that we have connected with the IP address of so and so. Then we did it. But here, 60% of the enterprise are connected with wireless devices. That means these wireless devices are especially used for establishing the wireless local area network. So especially this wireless local area network is used for avoiding the wire connectivity. So much wire has to run in the campus or in the company premises. So to avoid that, they used to use this wireless device. But to connect the servers, so obviously they require wired connectivity. So the target of any hacker is to go for catching this particular servers. So that is the reason, as a penetration tester or ethical hacker, one must know both the wired and wireless devices and how to perform the hacking on wired and wireless devices. And not only this one, also penetration testing the wireless and wired devices. Along with this one, we'll see afterwards in one or two lectures that mobile hacking. Nowadays, look at in the statistics itself, it is mentioning that 100% of smartphones are equipped with the wireless networking. So, in among these smartphones, around 90% of the smartphones are coming with the Android phones, Android operating system. So, we'll also see what are the possible Android hacking techniques that we can use to hack a Android smartphone. And finally, the recent studies, that is according to the statistics correction, recent studies shows that more than 1 Gbps, here capital B, that is gigabytes per second, data can be transmitted over wireless medium. So that much data can be transmitted over wireless medium. Nowadays it may be improved, it may be somewhat older statistics. So that means these are the advantages with which this wireless connectivity is available. Here, why we are calling it as Wi-Fi means Wi-Fi is nothing but wireless fidelity. So this wireless fidelity, you make use of the 802.11 standard, that is IEEE 802.11 standard. And in that 802.11 standard, there are several other variants are there, depending upon the bandwidth it supports, depending upon the data rate, security features, etc. Several categories are there. See, that is the reason this particular Wi-Fi is widely used. And one more reason why this Wi-Fi is widely used is the most of the wireless devices that what we are discussing so far are using ISM frequency bands. What is this ISM frequency band? ISM means industrial, scientific, and medical frequency bands. These ISM bands are unlicensed bands. That means anyone can use these bands. So, especially like 2G spectrum, 3G spectrum, 4G spectrum, these are the frequency bands with which the mobile signals will be sent. These signals for transferring the signals in that particular frequency, government permission is required. The concerned government, the local government condition, uh, uh, permission is required. So that is the reason every year the government will go for the auction of the spectrum space, so that the telecom providers will purchase that particular spectrum space and will will transmit that signal in the band that they have selected or band they have purchased. So that is an authenticated and authorized band to use by the particular telecom company. But in case of ISM frequency bands, those are unlicensed bands. Anyone can use these bands. So what are the different frequency bands available here? 868 megahertz, 915 megahertz, 2.4 gigahertz, and 5 gigahertz. So nowadays, whatever the frequency bands we are using, especially like Wi-Fi router at our home or Bluetooth devices, all these are using the same frequency bands, like 868 megahertz, 915 megahertz, 2.4 gigahertz, and 5 gigahertz frequencies. So these four frequencies are unlicensed bands. Anyone can use this. So that is the reason these Wi-Fi devices, since they are built upon these frequency bands, so you without any government permission, you can make use of this. So that is the reason these wireless devices are popularly used for establishing the wireless LANs within the organization. So that is what the interesting fact behind this wireless devices, why they are used in the wireless in establishing the local area network within any organization or company. Among this one, 868 megahertz are popularly used in the European countries. 915 megahertz and 2.4 gigahertz are popularly used in US and other countries. And India also 2.4 and 5.5 gigahertz are popularly used. So whenever you purchase any Wi-Fi router or any wireless device, you look at the band which was mentioned there. It will mention the various bands over there, and also several channels. So this band means exactly the wireless will not the data will not be transmitted over exactly 915 megahertz or exactly on 2.4 gigahertz. However, there is a band range will be there 2.0 to 2.4 gigahertz. So and 5.0 to some 5.x gigahertz. This range will be there. Within this range, the frequency will be set, and within this frequency, there will be some several channels will be there. Around 20 or 21 channels in case of Zigbee devices. In case of Wi-Fi devices, around 11 channels, 12 channels. So like that, depending upon the IEEE standard, channels will be fixed. The senders and receivers will make use of those channels for transmitting the data. So for these channels are of thin size, and every channel will be separated with a guard channel. Guard channel means the channel should not be overlapped. So whenever you mention that, okay, I am sending on the channel 6 in the frequency of 2.4 gigahertz, then the receiver must also tune to the same frequency and should listen to the same channel. Then only this kind of communication will takes place. The communication takes place between the sender and receiver. But in general, generic wireless devices that we are using in our devices will search through all channels first. So that is the reason you might have experienced it. You may be having a Bluetooth headset or Bluetooth speaker or Bluetooth audio receiver. Whenever you have turned on the Wi-Fi devices, other Bluetooth in our other mobile phones, and Bluetooth headsets and Bluetooth receivers or some other thing parallelly in at your home, sometimes your Bluetooth headset sometimes may not be detected. The reason is all are working on the 2.5 gigahertz only, so they might have transmitting the data over a particular channel. Then thereby, thereby the channels data may be overlapped or maybe crisscrossed, so that the continuously using headset, the Bluetooth headset, may not respond to the request or may not turn to the may not give you the sound output, etc. So because of this clumsiness in the channels, so sometimes your system will stop recognizing. So for this, the simple remedy is turn off all the devices or all wireless devices at your home and wait for around 10 to 15 minutes. Then turn on your Wi-Fi device, this Bluetooth headset or Bluetooth device. Then the signal, then the mobile phone or the music transmitter or whatever it may be will start recognizing that sound device or the Bluetooth speaker or Bluetooth headset. So this is the simple thing. Because of the clumsiness in the signal transmissions within the same band, sometimes the signals may be overlapped and the receiver is unable to do it. Why I am telling all these things means, as an ethical hacker or a penetration tester, one must be aware of these bands. Okay, whenever you purchase any Wi-Fi router, you can go to the administration section of that Wi-Fi router via 19.168.1.1 from your mobile uh, from your PC browser and connect to that particular Wi-Fi router, and that in that you can check what are the channels supported by that particular router. That is for exercise for you. If you are having a Wi-Fi router at your home, connect to the Wi-Fi router via browser and go through that Wi-Fi router. Usually, the Wi-Fi router's username password will be admin and admin or admin123. If you might have changed the password, just to go through that by entering the password that what you have changed, and in that you will be finding the hardware section. In the hardware section, you will find the channel and frequency and number of channels to be used, default channel to be used, etc. So these kind of things you can find there. Once you set it, then you are supposed to reboot the Wi-Fi router. Then it will start working on transmitting the data over a particular channel. So these are the basic things as a penetration tester one must know instead of directly going into the tools and all, because you can capture the data via the monitoring tools or sniffing tools, but you should know from on which channel or on which signal range you can capture the signal or you can jam the signals. So this kind of awareness is required. Then only you can have a perfect sketch of how to hack or how to perform penetration testing of a wireless device. Next, we'll move on to the wireless terminologies. So wireless terminology is nothing but here the different terminologies that are used, like GSM, Global System for Mobile Communication. It is an international standard for mobile wireless communications. Association is the process of communicating with the access point. So communicating a client and access point. In this association, sometimes key exchanges will happen or password exchanges will happen, and accepting of the connection is required. So many things will come into this picture. Next is BSSID, which is called a Basic Service Set Identification. This is just like the MAC address of the wireless access point. Okay, it is a medium access control address of the access point. Next is hotspot, a location that provides wireless access to the public, such as coffee shop or airport, with which you can connect to that particular access point. Access point, a hardware or software construct that provides wireless access. So this access point may be a software also. That, for example, my free Wi-Fi is a tool you can download also. It is a free Wi-Fi tool on Windows operating system. You can create an access point on the fly. Whatever the internet that is coming onto your computer via wired or wireless internet can be sent out, and you can fix an SSID and you can give some passwords and all. So anyone who wants to connect with your computer, they can connect and they can share the internet. So this kind of thing is said to be access point. And as I just now I told you, ISM means industrial, scientific, and medical bands. And bandwidth, how much speed is available for the device, or how much bandwidth is available for the device, how much data rate or data speed is available for the devices when it is connected to any access point. And one more thing here, you are supposed to remember, in bandwidth again, here two categories will be there. Okay, up speed and downlink speed, uplink and downlink. Uplink means the files that you upload into the internet. Downlink means that you are downloading from the internet. So you are, for example, if you might have connected to a mobile network like a 4G network or any other network, 3G network, then the downlink may be fast. Sometimes uplink may be slow. So if you want to upload, for example, if you want to upload a 5 MB file or 6 MB file via WhatsApp, so uploading will take long time, but sometimes downloading will take very fast. So just if you click it, then immediately it will be downloaded within 1 or 2 seconds. But it cannot be transmitted over the WhatsApp or something within 1 or 2 seconds. The reason is uplink is slow. So in this bandwidth, again, the uplink and downlink, both the things will come into the picture. So you should not, if you are a YouTuber or if you are a Instagram user or something where you want to frequently upload the videos, then you should also check for uplink speed. So whenever any service provider comes to you and asks that we are providing this much bandwidth and this much speed, etc., first you check for the uplink and downlink, whether they are giving the same uplink and downlink as they are saying. If they are saying as we will give the 100 Mbps speed, okay, both in uplink and downlink, then it's well and good. So usually it will be in the downlink but not in the uplink. So that you are supposed to cross check. Next one is wireless standards that we will see here. So as I told you, wireless fidelity Wi-Fi will be based upon the IEEE 802.11 standard. So here 802.11 standard is further classified into A, B, G, N, A, C, I, etc. So that is the reason whenever you purchase any laptop or wireless device, there will be having standard IEEE 802.11 slash A slash B slash G slash, like that it will be there. That means at what frequency they operate and how much speed they support. These are the things that will be listed over there. So here 802.11A is it will work at the frequency 5 gigahertz, which is an ISM band, and which offers maximum of 54 Mbps and will work up to the 75 feet range. So where in case of 802.11b works in the 2.4 gigahertz, the speed is 11 Mbps. Okay. Next is 802.11g, 2.4 gigahertz, 11 Mbps, 150 meters range. 802.11n, 2.4 by 5, 54 and 100 meters range, 100 feet range. 802.16. This is another wireless standard, which is also a kind of not wireless, metropolitan area kind of thing, which is somewhat a larger distance. It will operate from the 10 gigahertz to 66 gigahertz, and speed will be ranging from 70 to 1000 megabytes per second, and ranges up to 30 miles. And here Bluetooth is 802.15.1 standard, IEEE 802.15.1 standard, okay, which will operate at 2.4 gigahertz, and depending upon the generation, currently Bluetooth 5.0 is going on. So Bluetooth 2.0, 3.0, 4.0, like that you can see the version. Whenever you purchase any Bluetooth headset or any other thing, you can see the version number, Bluetooth 5.0. Currently the 5.0 and some other upgradations are also coming in the market. So this 1 to 3, that is up to the third generation, the range is up to maximum of 33 feet. Now the Bluetooth 5.0 can connect up to 50 meters or 30 meters, they have mentioned. So that also is available. And there is another wireless standard popularly used in the wireless devices for the low power communication, which is called Zigbee. So this Zigbee is 802.15.4 standard. Okay, Wi-Fi is 802.11 IEEE standard, While in case of WiMAX is 802.16 IEEE standard, Bluetooth is 802.15.1 standard, that is IEEE standard. Where in case of Zigbee is 802.15.4. Okay, these are the standard numbers, and the Bluetooth and Zigbee both will use 2.4 gigahertz frequency. Where in case of Wi-Fi only, you will be having different frequencies. Here 2.4 frequencies there, and 5 gigahertz frequencies are also there. Whenever you use the 5 gigahertz frequency transmitter, then obviously you have to there are receivers are there that receiving end will check for what type of frequency it uses. Whenever it is having 2.4 by 5, that means it will work in both the some Wi-Fi devices will work at the both frequencies, so they can easily connect to that devices even though they are operating at the transmitter is at the 5 gigahertz frequency. So this is what these are the introduction to the wireless standards. Next, we'll see the wireless antennas also. And people used to use wrong antennas and used to hack the try to hack the systems. But usually, you should use the perfect antenna to hack the any wireless device. So here, most commonly, three type of antennas are used. In most of our Wi-Fi, Bluetooth, and Zigbee standard, these three, even including WiMAX, all these standards, the middle one that is called omnidirectional antenna will be used. Omnidirectional means the radiation power equally distributed in horizontal directions through the earth curvature. That means through the in a spherical manner. In a spherical manner, the signal will be spreaded. So that is the reason, even though the Wi-Fi device is at the top of your top at the place somewhere on the top of the wall or somewhere, even though you sit in the corner room or in anywhere, you will get the signal. The reason is it is spreaded throughout your home in a omnidirectional manner or a spherical manner. Where in case of Yagi antennas, this Yagi antennas are our old TV antennas. In my childhood, especially, we used to have this particular antennas at top of our building. So whenever any rain comes or flood, this heavy wind comes, these antennas will be displaced. So next day morning, we used to go there and we should put in the direction towards the TV tower in our town. Then only we used to get the signal correctly and picture will be clear. So these kind of things used to be happen. So these are the unidirectional. That means the direction of the transmitter and receiver must be in the same direction. So that is the reason to understand this, they have placed there multiple directors are there. These multiple directors, usually detect the signals and will take the signal and will transmit to the TV. So this Aggie antennas will work like that. It is in the unidirectional. Means the transmitter and receiver must be in the line of sight, at the same line of sight. It is just like your infrared communication. In older mobile phones, somewhat little bit older mobile phones, you can see IR also. Whenever you want to transmit data from one phone to other phone, both the phones must be kept one side by side, and this IR sender and receiver must be side by side. Then only the data communication takes place. It is just like your TV remote. So television remote and Tata Sky remote or any other set-top box remotes, you have to keep in the same line of sight towards that particular set-top box or TV. Then only the the remote will function or remote will work. So this is what is called line of sight antennas. Where in case of parabolic antennas, so the parabolic antennas, whenever you look at these antennas, you will find you can realize your dish TV antenna or Tata Sky antenna. So it is just like a parabolic antenna and is especially used for the receiving the signals from the satellite. So this is the antenna. So in which in these are the three most commonly used antennas nowadays. In which the omnidirectional antenna is the antenna that we are supposed to target, because the omnidirectional antenna is having a specific feature that the signal will be transmitted over the earth curvature, and it is the power is equally distributed in all horizons or horizontal directions. So this is the antenna that we popularly use in all the wireless devices. Once the wireless devices are there, how the authentication will take place? In general, in the wireless devices authentication, two types of authentications are there. One is open system authentication category, and second one is shared key authentication. Open system authentication means in which if any client wants to communicate with any access point, access point is just nothing but your hotspot or Wi-Fi router which was placed there. So if any client wants to communicate with the access point, the client will send first the authentication request to the access point. Now the access point will communicate by authenticating the client. Then the client will directly connect to the network. Here there is no much communication takes place. It is just like connecting to the public Wi-Fi or public access points. So here much authentication will not take place. So always this type of authentication is dangerous, and only validating of the client is required, because in this validation the access point always check for what is the IP address of the client and MAC address, and simply it will send a key automatically. With the key, the client will communicate. So this is the open system authentication. Where in case of shared authentication, shared key authentication is nothing but in which the client will first send the authentication request, then wireless access point will send the authentication response as a challenge. So this particular client has to solve that challenge. It is in the encrypted form. So associated request encrypted challenge will be sent back to the authentication access point, and the access point in turn will check the challenge. That is what they called password checking or some other thing. If the challenge is accepted or challenge is successful, then association response will be sent back to the client. Then the client will full-fledgedly connect to the wireless access point, and the WEP, wireless encryption protocol, related data frame to be sent to the access point, and thereby in turn it will be sent to the wired networks. This is the communication model between the client and access point in case of shared authentication, shared key authentication. So in this, usually many of the access points will work in this way only. So first the client has to request for the access point. Then if the access point don't have any password or some other thing, then it won't ask for you any password directly. It will be connected. But sometimes whenever you click on the access point that you have identified in your system, then first it will try to connect. Then afterwards immediately it will ask you that what is the password. So you are supposed to enter the password. Then the password will be verified, and then a temporary IP address will be allocated. Obtaining IP address, then it will be connected. So this kind of steps will happen. Here, as many number of steps are there here, just like you look at here, TCP three-way handshake. As many number of steps are there, it is a beautiful chance for the ethical hacker or penetration tester or any violent hacker to break this particular communication and communicate with the access point with his computer. So this is here the wireless hacking is totally based on breaking this communication. Okay, breaking this communication or injecting the false packets and turning the entire control to the attacker system from the client system. This is what the main idea of this wireless hacking in this especially in this particular context. We'll explore some wireless encryption mechanisms. Then in the later lectures, we'll see in detail how these particular wireless encryption mechanisms work and how to crack those wireless encryption mechanisms. The first one is wired equivalent privacy. So here wired equivalent privacy is the first and foremost security mechanism that has been included for the wireless network. So they have taken the security features from the wired networks, and they didn't done much groundwork, and they didn't done the feedback collection testing in the real environment. They have released it. So basically, this wireless encryption equivalent privacy will use the RC4 encryption. Basically, this RC4 encryption was breaked a few years back, So any data that was encrypted using RC4 mechanism can be easily broken. Even MD5 passwords can be broken. We have seen via the uh, the system hacking where whenever you find the MD5 passwords, then that is MD5 hashed format, then easily there we are going to retrieve the password by performing dictionary attacks or any other attack. So here RC4 is a mechanism for the encryption, and RC5 is also an encryption mechanism. So this RC4 mechanism was used by this wired equivalent privacy. And to say RC4 mechanism breaking, so this RC4 was broken by our Indian only. Okay, so a researcher from IIT Madras in around 2011 or 12, as a part of his PhD work, he has shown that how to break this RC4, and he developed a tool to break this RC4. From that time onwards, no one is using RC4. Okay, so this is what the part of cryptology. Okay, cryptology means the art of breaking the secrets. Cryptography is the art of making the secrets. Okay, so this is wired encryption, wired equivalent privacy. Next is to have more security over the wired equivalent privacy. This Wi-Fi protected access was developed. Wi-Fi protected access was the successor of WEP and was intended to address many problems that plagued with the wireless encryption, the wired equivalent privacy. WPA uses a temporal key integration protocol and message integrity code. These two will be used in this WPA. So whenever you turn on your mobile as hotspot, whenever you enter the password, you will be having the options like none and WPA or WPA2, like that. You will be having options. So this is the WEP. This is the WPA, which is the successor of WEP and uses the temporal key integration protocol and message integrity code. Where in case of WPA2 is more secure than the WPA. Okay, so nowadays most recent mobiles are having the security feature as the WPA2. There is no WPA and WEP. Old routers you will find the WEP and WPA, but but the recent devices you won't find this WPA and WEP. Only WPA2 key authentication will be there. Okay, so WPA2 is the successor to the WPA and was intended to address the problems with the WPA. We'll see what are the problems with WPA. WPA2 is much stronger and uses together encryption in the form of the AES standard. AES standard, advanced encryption standard, will be used, and CCMP, counter mode, and cipher block chaining message authentication code protocol will be used. So we are not going details of how these protocols work and all. We will see what are the features of these protocols. That's all. Okay, because we should know aware of what is the feature and functionality of this protocol. So it is sufficient for us to know what is the functionality of WPA2. The standard also comes in the version that uses stronger stronger systems such as extensible authentication protocol, TKIP, that is which is already used in WPA, and also AES with longer keys. AES 128-bit encryption, 256 encryption. So like that, longer keys can be used. And a little bit variant of WPA2 is WPA2 Enterprise. Is a version that incorporates EAP standard as a way to strengthen the security as well as scale the system up to the large enterprise environments. That means for example, if you consider our university where around 800 to 1000 computers are there, as I assume that. So I want to provide that much security to that many computers, stronger security to that many computers. Then this WPA2 enterprise version can be used to provide the wireless security in the campus or in the enterprise. So these are the 4 security standards for the wireless is available. We'll see one by one in the next lectures. What are the functionality of this one, and is there any tools are available to capture and break these encryptions, and what are the countermeasures that we can use. Along with this Wi-Fi, this is related to the Wi-Fi devices. That is especially wireless. Whenever I am speaking, currently it is in the context of Wi-Fi, and there is another wireless device that will be popularly used called Bluetooth devices. We will spend one lecture on the Bluetooth device hacking and Bluetooth architecture and its hacking procedures, tools available. Then we can conclude this chapter.